Okay, so we spent our morning looking at how to work with curves. As a small little reminder, that goblets and glasses assignment, that's going to be due next week. I think overwhelmingly people are marching towards completion of that. Make a good render, put some good materials, look at your lighting a little bit, and then give me both the LXL and the rendered project file back to the Dropbox by this time next week, and life will be good. Over the last couple of weeks, we spent a lot of time talking about Booleans, right? Last week, if you remember, we spent all of our energy talking about the tiling texture workflow, and to get to that point, we had to create some really compelling geometry for our house, and we used Booleans to help us get there pretty quickly. However, Booleans are really tough to work with, right? They can get kind of squirrely really fast, and if you're not on it, if you're not present, as I say, in the modeling process, it can be very easy to infuse a lot of technical errors into your mesh pretty quickly. So we got to be careful. And they also present some big challenges for us on surfaces that are curved, right? On a house, Booleans are a natural place to begin because everything on most houses, unless you're living in like a hobbit hole, okay, is going to be very planar, very flat, very square, okay? But when we work on curved surfaces, like our goblet, for example, Booleans then present some big-time problems for us, right? In every sense, a Boolean is kind of like a cookie cutter, okay? It's going to just stamp out a hole in our object. If we're not careful, if we're not looking exactly where this hole is going and how the computer is constructing this geometry, we can cause more problems than solve, okay? So one of the biggest problems that we have to mitigate is, of course, the creation of an n-gon. And you saw this all over the place last week with our house. Let me show you a quick little example and bring to the surface the problems that Booleans solve for us, right? I'm going to just infuse a simple little square here. Okay, looking good. And let's do this. I'm going to turn off my grid just for a second so I get that out of the way. And I'm going to make a box. Go back a couple weeks, not 2 weeks ago, was it not last week, but the week after, we did that little birdhouse, right? And we had to cut a hole on the inside of our birdhouse, right? Now, and that's a good thing, and we used Booleans to do that for us, allowed us to stamp in that hole in our shape pretty quickly. But what we generated was a non-compliant surface type, a surface, a model, if you will, that's infused with a lot of n-gons, right? Let me show you what I'm talking about. I'm going to rebuild that little example here real fast, okay? And here, I'm going to do this. This is a cool little trick. I'm going to delete that top polygon in my cube, and then I'm going to run a great tool on the remainder of my cube called Thicken. Thicken is going to be like kind of like an instant wall tool, right? Check this out. If I run Thicken, and if I grab the blue handle, I can push and pull some walls, okay? Kind of create the illusion of thickness on a piece of geometry. The Thicken tool is something that you'd only want to do on a traditionally two-dimensional shape that's hollow on the inside, and it does a darn good job of making some walls, okay? So let's just pretend that's my birdhouse, and then I want to go in and stamp a hole kind of right around in here somewhere, okay? A circular hole, not a square. So, of course, naturally to do that, what we're going to need is some cutting geometry, and I think I just may put a basic unit primitive cylinder inside of our mesh. Now that's way too big. That was like a 24-sided cylinder. Let's make it, let's make it something a little bit more manageable, like an 8. There we go. Oops, excuse me. Let's extrude that shape out a little bit, and let's get that centered in our scene. I'm working around the origin right now intentionally so that I can keep all of my shapes pretty much in line with each other. The origin is a great helper because my cube is at the origin and my cylinder is now at the origin, so I can deduct that this cylinder is in the center of that square. So with this in tow, and let me turn my active meshes viewport property. There we go. Hold on a sec. Inactive meshes. I want this to be wireframe. There we go. It's a little bit easier to see what's going on when your inactive meshes are being chosen to draw as wireframes. Yep, that's good. And now what we can do is we can run the Boolean, very similar to what we did last week. My cutting geometry goes all the way through the mesh. So I'll run the Boolean. I love the solid drill. And let's do slice like we did last time. Boom. Awesome sauce, right? If we turn off our cylinder, which is the cutter, you can see what's left. And I'll turn on the visibility of my vert so y'all in the back can see what's going on. There it is. Awesome. There it is. Pretty cool. And we can see the surface that the computer's created for us. I'm going to grab the inside and the outside and bridge them just to create a simple little opening in my pseudo birdhouse, if you will, going back to the example that we used a couple weeks ago. So here's the big problem, okay, and why we really need to focus in on the Boolean system and the problems that it infuses into our mesh itself, okay? If I start looking at the number of sides that are on this front surface here, this front polygon, man, I have a big problem, right? This is a gigantic n-gon. If we count the verts that are associated with that one polygon, or this one side, okay, it's really easy. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's a 12th one down over there. So that's a 12-sided surface. This is no bueno. This is not going to work for us, right? We need to remember that as 3D modelers, we're participating in a very long production pipeline. We're the first link in the chain. Our models are always going to be handed off to someone else inside of our production pipeline, right? They're going to be handed over to a UV mapper or a texture artist that's going to paint the outside. And then if you're working on a big film, that model is then going to get handed to a character rigger or some sort of articulator that's going to infuse a mechanical core that's going to make this object move. And then that project file is going to get handed over to an animator that's going to animate it. And then that project file is going to get handed over to the visual effects guys. They're going to add any number of things like wind and smoke and fire. Then that stuff is then handed over to the renderer, right, who's going to be physically responsible for drawing the frame, putting the lights, the camera movements, all that jazz in. And then that file is then going to be handed over to a compositor who's going to finalize the shot. And then that file is going to get handed over to the editor who's going to splice it into the film itself, okay? And then that file is going to get handed over to the colorists who's going to actually do the final film grading and output that's going to show up on the film itself. So we're the first link in a very long chain, okay? So it's important that we establish a very strong foundation since the entire production is going to be built off of the work that we do, right? N-gons are a big problem, okay? We know likey the n-gons, right? There's a lot of apps inside of our production pipeline don't support n-gons. They don't know how to draw them. They don't know how to render them. They don't know the subdivision surface algorithm doesn't really work with n-gons that well, okay? Shoot, if you're taking this over into a game engines only understand quad polygons and triangles, and they just flat out won't draw that surface, okay? So we need to get this shape out of an n-gon and into a quad polygon mesh pretty quickly. Booleans are a natural first step, but they're not the last step. We still have some work in here that we need to do to very quickly get this into a compliant surface type that I then feel comfortable handing off to the next person inside of our production pipeline, okay? So let's just do it real fast. This doesn't take that much energy. Let's jump in. Okay, here we go. So I need to go ahead and slice this mesh up into a whole series of quad polygon polygons, okay? So I'm going to work with some discipline here. I know I need to slice up my mesh. I'm going to do all the vertical slices first, and then I'm going to go back in and do all the horizontal slices, okay? That way my brain is focused on one direction and I'm not confusing it with trying to mix and match the slicing direction. So I'm going to slice vertically, okay? I'm going to use all of these things in here as the starter points for my slice operation, okay? Ultimately, what I need to generate here is a whole series of edge loops that start at certain locations, okay? It's going to ultimately look like this along the mesh. I won't do the bottom ones. It's the exact same pattern. But this is where we're going, okay? Now, each one of these slices, each one of these new edge segments that I'm going to infuse and slice into the mesh needs to be a loop. Define for me real fast what a loop is. That's right. The way I think of it in my brain, it's like a row of edges, right? It's a row that wraps all the way around the mesh, then connects back onto itself, right? Good modelers try to put these loops into our mesh as much as we can. It makes it a very highly editable mesh that we can control with simple selections, okay? So, oops, excuse me. So what I need to do is that I need to make sure that my loop, goes here, and then across the top, then all the way back down the model that way, and then across the floor, up the back of the wall, and eventually it'll go woo all the way back to the mesh and end up right back there, okay? That's the goal. And luckily for us, the slicing tools inside of Modo allow us to do this very, very quickly. I'm going to make sure I'm slicing the correct geometry by selecting the geometry that I want to edit, which represents this loop in here. There we go. Happy camper. Notice that I'm not selecting this interior row in the opening of the circle. That's to ensure that I don't get a double polygon right in this area. Okay? All right, here we go. I'm just going to look at it from the front, and this is why I love working in Modo, because if we pair the snapping engine with all of our tool pipe, like our slice tools, this can go very quickly. So I'm going to turn on a little vertex snapping here. I'm going to enable my snapping engine and simply return to my slice tool that we've been working with most of the semester and start rocking and rolling. There we go. Just going to hold down the shift key and reactivate that slice. Ah, awesome. And that's it. That's all I need to do that way. And then let's drop the tool and look at what we've done. So, looking good so far. Yep, these down here go all the way around the mesh, which is what I'm after. These in here, they loop back onto themselves, which is just fine. They don't go down because of the opening, and I'm a happy camper about that. That's no problem. With all the vertical ones done, let's just quickly go in and select the polygons to do all the horizontal ones. Now, I'm going to be a smart modeler, and I'm going to select both the outside of my cube and the inside at the exact same time. And I'm going to do both sides of my surface at once. Oops. Look at my scene from the front. And once again, if I employ my snapping engine with the slice tool, I can do what I want to do within just a couple clicks. And there it is. Mission accomplished. That's what we're after. Aha, awesome. Now, because we've gone ahead and worked hard to infuse quad polygons into the mesh and sliced out my, my geometry, I no longer need these corner guys, right? These diagonal lines in here were ultimately created by the computer. It's trying to connect the original Boolean opening with an existing vert or an existing edge segment on the original mesh. So we don't need them anymore. They're kind of just getting in the way. So I'm going to select them and hit the backspace key. There's the other one down over there. And there it is. That's what we got. Awesome. Okay? I'm liking this. This is a good shape. It's all quad polygons, been sliced up, looking pretty good. Okay? Now, as a traditional polygonal object, this is legit. This is fine. I'm done, right? But man, I being a modeler, okay, I want that opening in the center of my birdhouse to be perfectly circular. What can I do to make that opening, that circle, perfectly circular? I heard someone begin to say it, and you're right. Subdivide. Hit the tab key, right? As we know from our previous experience working in Modo, the tab key employs the subdivision surface algorithm, right? And look at it. Yeah, rock and roll. This is good. This is good stuff. Now the circle here is perfectly circular, but what happened to the rest of my mesh?
So you can just highlight that.
Well, and if we just highlight this and hit tab, it's going to break it. Okay? So we have to subdivide all or nothing. We can't mix and match instead of a contiguous polygonal piece. So we have some work in here that we need to do. Yeah, we need to start slicing up and adding some additional edge segments on the cube now to shore up those transitions and make them a little bit tighter. Okay? Let's do it real fast. It doesn't take much work. And I think what I'm going to do is, I'm just going to run some loop slices in here. And I'm doing this just because I get a little bit more control. So loop slice, count of 1. There we go. Just going to place the loops where I want them. There we go. That's good. So if you remember back to our conversation about subdivision surface modeling, right? If this is the original edge, we have to generate 2 additional edge segments right around here, right? One above and one below. okay? Sandwich the original edge with two new ones. Let's do it again over here. Now for this one, I think I'm going to be pretty smart. Once again, I'm going to use loop slice, but I'm going to use a count of 2 and change the loop slice mode to symmetry, so I'm doing both the front and the back at the same time. Right around there. That's pretty good. I like that. Haha. Let's do this back corner. Loop slice. I don't need a count of 2. I want to change my mode back to free so I get to interactively place that loop where I want it to go. Oh, I've already done that loop. I'm sorry. Yeah. So those are all good. If we hit the tab key, starting to flush out. Now we need one down here at the bottom. I'll make sure I get the inside as well. Cool. Yeah, and we're getting there. We're getting there. I think I'm missing a loop somewhere. Yep, I'm missing a loop up here at the top. And I'll also make sure I get the inside too. Coolio. And then to really tighten that transition in here, I think I'll do a loop slice, a count of 2, a mode of symmetry. There it is. And I'm a happy camper. Okay? And then if you look, the opening here, perfectly circular. Now, I could go in and add some additional geometry, like let's say in here, to get it really good. And I'm happy with that. That's not actually too bad. Okay? If I turn off the visibility of my verts and my wireframe overlay, and just evaluate the shape, I'm pretty happy. That's actually not a bad model. So good for me. Yay. Pat on the back, Pat. I did it. Woo, awesome. Let's pretend that we're making this thing. I go over to my modeling supervisor, and he or she looks at it and says, Pat, awesome job, man. Really great work. However, maybe the hole is too small. Or you know what would be better? Instead of it being a perfectly circle, what if it's like just like a half circle, right, opening instead of a full circle opening? And then I go, yes, sir, ma'am. I go back to my desk. And the moment I get back to my desk, I start freaking out, right? Because now I have to like completely remodel the entire thing to make it go from a full circle to a half circle, right? This is not an easy change. Welcome to the rest of your lives as 3D modelers, right? Making big changes like this require a tremendous amount of effort, especially when we're working with subdivision surfaces, okay? Thus enter Mesh Fusion, okay? Mesh Fusion is a game changer, okay? Mesh Fusion allows us to still work inside of this Boolean pipeline, if you will, but it keeps everything live, okay? It allows us to interactively change the input mesh items to create the final result, and it's pretty neat, okay? However, before we get into this, there's one big thing, one big architectural, kind of foundation idea that we need to reinforce before we go any further, okay? Mesh Fusion works with subdivision surfaces exclusively, okay? As a rule, we can't break it. We have to work with sub-D objects, okay? Up until now, we've only been working with the, I hate to say vanilla sub-D algorithm, okay? But there's actually 2 different types of subdivision surfaces that we can create inside of Modo. We've been working with what are commonly referred to as the Luxology subdivision surfaces, but there's another one, okay? There's another one called Catmull-Clark subdivision surfaces, and this is the gold standard. There's 2 different algorithms, okay? As we've talked about before, Ed Catmull is the granddaddy of the computer science industry, right? The computer graphics industry. He has invented many of the core technologies that we use to this very day. You're about to see one of his major contributions in play here when we create a Catmull-Clark subdivision surface, okay? Does anyone know where Ed Catmull currently works? He works at Pixar. He's the president of Pixar, okay? Ed Catmull is the leader of the original computer graphics group at Lucasfilm that was sold. Does anyone know who the original computer graphics group at Lucasfilm was sold to? George Lucas was only really interested in the technology. He really didn't want to make computer animated films, right? He knew that computer graphics were going to be a big part of the future of filmmaking, but he only saw it at the time as something that could be used in the effects industry, right? To help make Star Wars. Not to do what we commonly refer as like a Pixar animated film, an entirely computer-generated film. He wasn't interested in doing that. He just wanted the technology. The computer graphics group had a pretty intense interest in making films, right? They had done a couple short films to prove the technology, and they wanted to do more of that. They wanted to do feature-length animated films. So George Lucas said, fine, you guys can go do this. You guys are so expensive. The overhead and the research that you're doing is amazing, but it's the most expensive stuff on the face of the planet. I'm going to keep all the patents and the technology that you guys created, but if you want to creatively go off and do your own thing, I have no problem with that. None whatsoever, right? So he sold the computer graphics group to, does anyone know? Steve Jobs, right? The co-founder of Apple Computers, right? And then the rest is history, right? Ed Catmull was part of that transition, right? Because there's really three founding members of Pixar. There is the animator and John Lasseter, right? He's the big creative visionary. He's the director of Toy Story 1, Toy Story 2, Cars 2. He's now the chief creative officer at Disney. He is the big dog in the animation world right now, John Lasseter, okay? So you got John Lasseter, who's the animator. You got Ed Catmull, who's the computer scientist that comes up with the way to make these wonderful computer animated films. And then the third person is the money, Steve Jobs, the financier of Pixar. They really kind of make sure that they're going in the right direction, right? Without those three people, we would not be sitting here today talking about this, right? Long-winded story, getting back to the kind of point of all this, right, is that what we are participating in here in a moment is Ed Catmull's algorithm, right, for subdivision surfaces. If you look at the early Pixar stuff, did you see any polygons on there? No, you didn't see any sort of faceted edges, because that's because they were using Ed's algorithm, right? His subdivision surface algorithm. And the Catmull-Clark algorithm is the gold standard. It's like the best math, if you will, right? It's the highest quality, the most feature-rich algorithm for subdivision surfaces on the market. And up until about 4 years ago, Pixar owned it. And they kind of held on to it real tight, right? And they licensed the technology to other folks, but they charged a premium for that licensing fee. And then finally, everyone kind of came to a conclusion that this is the best algorithm on the face of the planet. Let's set it free. So they open sourced it, right? And now that algorithm is finding its way into all the major 3D modeling and animation apps. And I'm very happy, very, very happy that the Catmull-Clark sub-D algorithm is here inside of Modo, right? So that's the context of all this, right? In order for us to play inside of the Mesh Fusion world, we have to be working with Catmull-Clark subdivision surfaces, right? So let's look real fast at how we can determine if we're working with what's called the Luxology subdivision surface algorithm and a Catmull-Clark subdivision surface, okay? Luckily for us, it's a real nice visual indicator, and it has everything to do with where my cursor is rolling over inside the frame. I know it's kind of hard to see on the projector here, but as I roll over each one of these polygons, what's its rollover highlight color? This is washing it out. If you're playing along with me on your local screen, you'll see that it's kind of like a pinkish, light purple hue, okay? It's very, very subtle. Remember that. Luxology sub-Ds, pinkish, light purple, okay? I'm going to unsubdivide my mesh by hitting the Tab key, okay? And to get us into, and I'll turn my wireframes back on so we can see some stuff, okay? So unsubdivided mesh, okay? Now, to get us into that Catmull-Clark world, it's still the Tab key, but now we're going to add the Shift key in there too. So it's Shift Tab. Shift Tab is going to give us Catmull-Clark subdivision surfaces. And now, what's the rollover color? Green. So the pinkish purple one, those are the Luxology subdivision surfaces. And the green is the Catmull-Clark, okay? Once we're working inside of a Catmull-Clark subdivision surface, we now can begin to play inside of Mesh Fusion, okay? So Catmull-Clarks, we have to be using Catmull-Clarks, okay? I think to demonstrate the power of Mesh Fusion, I'm going to use some preset mesh pieces that are already ready to go, that are already Catmull-Clark subdivision surfaces, and then we'll look at a more advanced example with the rocket ship stuff that I've given you on D2L, okay? So let's do this. We're going to basically rebuild this little project. So a box with a hole in it. And if you take some experience from what I had to go through to get to this result, that was some energy, right? Okay? That was a good 10 minutes worth of work just to get a box with a hole in it, right? Let's look at how we can do the exact same thing with Mesh Fusion. All right, so I'm going to create a new project file just to keep things clean and organized. And I'm going to still stay in the modeling tab. Oops, let me turn my Origin Action Center and Snapping Engine off. Okay? But in the modeling tab, in our toolbar, there's a tab way down here at the bottom that says Fusion. Okay? This is home to all of our Mesh Fusion tools. Okay? And there are a bunch of them. If you look at the toolbar, there's a lot of stuff going on. But where we begin is simple. We're going to begin with the cubic geometry preset library. Okay? It's this guy right here. That one. We're going to start there. If we click on this little button, you're going to get a little mesh preset library. Now, we're going to be navigating through a whole series of folders. Some of your, depending on who was working on this machine before he came in here, your folder may be in a different area, okay? But ultimately, where we're going, if you see this hierarchy, this is the top of the hierarchy, the folder hierarchy inside of our content browser. We want to go into Fusion Assets, and then Fusion Meshes, and then Cubics. There we go. We can find all of our little basic building blocks. So here's what we're going to do and what we need to do. We need to have some geometry currently residing inside the scene before we can start working. Mesh Fusion is a solid Boolean workflow, and you'll see this in play here in a second. Okay? It's very, very neat. So we need to have some meshes in here, and I think I'm going to use this Q medium cube. If I double-click on it, it gets added into my scene. So that's going to be my box. And let's see, there's a cylinder in here too. Yep, I'm going to use this Q cylinder medium, and I'll double-click on that to add it into my scene. All right, so let's get things rocking and rolling here. I'm going to use, I'm going to leave the, the box where it is, and I'm going to work in item mode. Mesh Fusion requires us to work at the item level. This is an item to item Boolean operation. So we're not going to be monkeying around with polygons here. Okay? You're in the wrong area, AJ.
Oh.
Down there. So item to item. So we're going to do all of our transformations, all of our changes in location, the size, and rotation at the item level for Mesh Fusion. Okay? So I got my cylinder item selected, and let's make it a little bit smaller. And I'm going to rotate it 90 degrees. And let's put it somewhere right around it. That's a real close approximation of my other mesh. Okay? Okay, so now that we have two items in the scene, let's start making a relationship between them. Okay? And start generating our first actual Mesh Fusion item itself. Okay? So here's what I'm going to do. I'm going to grab my box, and then I'm going to hold down the Shift key and grab the cylinder second. The selection order here is really important. So make sure you're registering in your brain which one you're selecting first. Okay? Looks like folks are generally with us. Okay, cool. So now let's do this real fast. It's a lot of fun, and I think you're really going to dig it. Once we have those two items selected, we now can go up and create our new Fusion item itself. It's the first button inside of our scene. We'll do New Fusion, and you're going to get a pretty intimidating popover, but let's start at the top and work our way down to the bottom. There's a lot going on in here, but it's really kind of simple. Of course, we're going to need to name this thing. This is going to be, I don't know, Frankencube. I like it. Frankencube, okay? So we give it a name, and then we get to choose which type of Fusion item that we want to create. For, I don't know, I think I've only created a schematic Fusion item like one time, because the tree, the 3D tree Fusion item, can do a lot, okay? So we're going to do 3D tree fusion. Then basically you can leave the next 3 settings as they are. All right, if you can turn off absolute strip width if you'd like, but show tree and new schematic workplace, you can leave all that stuff on. And then the most important part is what we're going to tell it to do. So this is why we needed to remember the selection order of our 2 previous items, right? I selected the cube first and the cylinder second. So I want to subtract, so I want to make a hole in my cube, right? I want to subtract the cylinder from the cube, right? So I'm going to choose subtract others from the first selected item. And the first selected item for me was the cube. I'll zoom out. It's going to think about it for a second. Subtract others from first selected. And then once we click on it, the fusion item is going to be created. And you can see in the wireframe right here what it's doing. To get us to a spot where we can see what's going on, I want to select my fusion item in the item list. There we go. And things are looking pretty good. Now I can actually see a hole inside of my shape. Okay. Real fast, before we go any further here, I want to draw your attention to some of our viewport settings over in our Mesh Fusion tools. And the one that you're going to see me using a lot is this source mesh visibility, which is just going to temporarily disable the visibility of all the items that are included inside of our Fusion system. There we go. Makes it a little bit easier to see what's going on. And there it is. Awesome. Looking pretty good. Looking really good. Now, you're probably saying, okay, Pat, this really isn't anything too special. I can do this with traditional Booleans, but check out this action, okay? This is where Mesh Fusion becomes really, really quite amazing. I'm going to turn the visibility of my source meshes back on again. And I'm going to select, you can just barely see it, it's kind of ghosted in the viewport. I'm going to select my cylinder. Okay, and let's see. Let's do Fusion View Settings. There we go. If you do Fusion View Settings, you'll see the Fusion item in the viewport as well. And this is what makes it pretty special. Okay, these are live Booleans. Any transformation that I do to one of the input mesh items, in my case the cylinder, is going to be immediately adopted by the Fusion item itself. Pretty cool, huh? So I can rotate it around, and the computer's going to figure out how to do all this, okay? Even have it go, oh, my guy's a little too small. So if I increase the length of it here, oops, wrong one, I've rotated it. If I increase the length of it, I can actually have it go all the way through the mesh, okay? I could bring that down again and cut the hole in there. This is pretty earth-shattering cool, okay? These are live Booleans, and the computer's going in and figuring out how to triangulate and create a quad polygon mesh for us on the background, okay? In about 2 seconds, I can recreate that example that took me 10 minutes to build a minute ago, right? And I can make changes to it on the fly. So if my art director comes in and says, Pat, the hole needs to be smaller, I go, hey, don't leave. Let's figure this out together, right? How small do you want it? And I made it too small. There we go. How small do you want it? Do you want it to be that small, or do you want it to be that small? Okay? And we can do it live in person. It's pretty great. Pretty cool, huh? Pretty cool. All right, let's continue talking about how we can say again? Sure. So the wireframe, so the couple things you can do the Fusion View settings. That may help. Yeah. All right. So let me go back in time a couple steps. Go hit undo. Okay. So now I'm back to a point where I just have the 2 cubic presets chilling in my scene, right? Now the selection order is important because I want to subtract the cylinder from the square. Okay. I want to make a hole in my cube. So if I grab the circle first, excuse me, the square first, and then hold down the Shift key and grab the cylinder, I now can go over into my Fusion tools and create a new Fusion item. Click on the button, give it a good name. I think we used Franken Cube, which is fine with me. Franken Cube. All right? And I'm going to turn off absolute strip width so I can show you a cool feature here in a second. And then, so this is like what you're creating, and then this is how it's going to be created. These are the actual Boolean tools themselves. And I want to choose, in my case, subtract the other mesh items from the first selected mesh items, which in my case is the cube. So once I go ahead and click on that, Mesh Fusion is going to take over, and it's going to do the Boolean operation for us. Aha! Awesome, huh? Awesome. Now, we're not quite done yet, because there's still some work in here that we need to do. If we're really trying to get the example that we had before, I need to create kind of a box, an opening in the box, okay? And this allows us to continue to add mesh items into our Fusion tree, into the Fusion system itself, and it's really kind of easy to do this, okay? However, first, we need to have some geometry that will cut a hole in the opening of my box up here at the top. So let's go back into my cubic geometry library, and let's find a cube. I think I'm going to see if I can find the exact same cube. Yep, here's the exact same cube that I used to describe the outside. And I'm going to make it a little bit smaller. And I'm paying real close attention here to the size of this strip of polygons, because that's going to be kind of the illusion of my wall thickness. And I want to make it a little bit bigger and move it up. There we go. All right. So now I need to get this mesh item, this second cube, as a member of our Fusion tree, this thing over here. And let's use this as an opportunity to really dig in and understand what in the world's going on with this tree, okay? Because this is a visualization of the Fusion engine itself at play here. And it's a pretty easy engine to work with once you understand the component pieces. Imagine in your mind here that the flow of information is going from this side of the tree this way, okay? So everything's going, the flow of data is going from the left to the right. As you can see, we're getting a nice, cool visualization of all of our input mesh items, right? These are our source meshes, the cutter pieces that eventually will pop out a new piece of geometry for us, right? Here's the cube. This is the cylinder down here. So we're always going to have our input meshes in this zone. But what comes next are all of these in here. These dots are important, as they represent the actual Boolean tool, the Mesh Fusion Boolean tool that helps generate the final mesh itself. And there are 3 of them. These are tools, okay? Tool operators, as they're called in the back end of the Mesh Fusion system. Let's define their roles, because they have unique roles. The green one, so this one right here, this is the union tool. Union, okay? This is going to add things together. It's going to make it feel like all these pieces have been glued together, okay? The middle one, this one, the blue guy, this is the intersect. So this is where we will see the difference between 2 mesh items. And the last one, the red guy down here at the bottom, this is subtract. So union is green, blue is intersect, and red is subtract. Okay? All right, so we have our source meshes, which then get told how to participate inside of the union tree. And then this last dot, this kind of, not the last one, the second to last one, excuse me, this light blue one, we're going to be playing with this one a lot, okay? This guy right in here is a branch operator, and you'll see this in play here in a second. Because this is a tree, and we can have many branches that allows us to isolate certain parts of our Mesh Fusion item from others. And you'll see this in a second when we start working with our rocket ship, okay? So we can have multiple branches of our tree, which ultimately get fed into this last one, okay? This last green dot here is a representation of the actual Fusion item itself. Think of this like the output. This is what the computer physically draws and creates for us, okay? We start with very basic building blocks with our source meshes. We pass them to a tool. We pass them into a branch, okay? Think of the branch as kind of like a group, okay? We can have multiple groups on our tree. And then the last thing it does is all that information is fed into the Fusion item itself, and the computer makes a mesh for us, okay? So for us, what we need to do next is start adding additional source meshes into our Fusion item. And to do that, and oops, excuse me, this is kind of, I want to move my tree. And if you click on the green dot, you can actually fire off the move tool and then just move it out of the way. Okay, there we go. Aha, awesome. So the tree is a member of our workflow. Okay, it's a live, interactive environment that we get to drag and drop things onto to change how the tool is working or how the tool is creating the final shape. So I want to subtract that last cube, that one. I want to subtract that last cube from my box. So I'm going to left click and drag it. You can see that we get the mesh icon underneath my cursor, and I want to drop it onto the red dot, bloop, which is going to subtract it. There we go. Let me go back in time, do it one more time. Okay. I'm going to left click. I'm in item mode, remember, because all this is done at the item level. Okay. I'm going to left click and drag this onto that red dot at the bottom of our Fusion tree, which will subtract that item from the outside box.
Why do we do that?
Well, if you look carefully, let me go back in time a step. If I turn off the visibility of this selected cube, it's just a hole. The cube isn't hollow on the inside, right? It's a solid cube. So by subtracting that big box, we create a box. Yeah, it's a different way of thinking, right? This is almost kind of like subtractive modeling, okay? If you're a CAD designer or if you've done a lot of solid modeling for the industrial design world, this is going to feel very comfortable and natural for you because in that world, this is kind of like all the feature set that we have. Well, it's really finely tuned, incredibly precise stuff, but the industrial design industry uses this solid modeling workflow paradigm as the central modeling process for that environment. So this is pretty neat, right? I like it. And what's great about this is that, of course, naturally we can go in and continue changing all of our source meshes, and it's going to update for us on the spot. Okay? Which is just, it's just so cool, right? It's like I can change things. I can art direct on the fly. Maybe I want to have it look like that for whatever reason. You know, it just, the opportunities here are pretty endless. I mean, try modeling that, okay? That would be pretty difficult. That'd be very difficult, actually, okay? And the fact that it's doing it all live for us is pretty great. It looks like I punched a hole in the bottom here. Let me raise up my box on the inside. Yep, there we go. Now it's not punching a hole up. And life is good. That's pretty fun, right? That's pretty fun. I'm going to hit the undo key a couple times, get my stuff kind of back to where it was. Let's do one more. Let's do one more. I'm going to do one that's kind of fun. Let's add another mesh preset in here. And I'm going to go get this little tuber-looking guy. And I'm going to make the most odd coffee cup on the face of the planet. Scale it down some. And I'm going to put it kind of right in there. Okay? Now, I want to glue this shape to the outside. I want to make this all one piece, okay? So if we cut holes in things using the subtraction Boolean tool, how do we glue pieces onto the outside? Does anyone remember which one it is? What tool? Union. The union tool in our Mesh Fusion tree. So it's the top dot in our Fusion tree. Okay, so I'm going to grab it real fast. So here's my tube. And remember, in the tree, union, intersect, subtract. okay? Glue, drill, and then the difference, intersect. All right, so I want to drag and drop my little handle onto the top, bloop, onto the top one, and there it is. Now we've glued that little tube onto the outside of my box. Yeah. Go back in time, hit undo. So I'm in item mode. I'm going to grab my little thing here. I don't even know what it is, a little half circle. And I'm going to left click and drag it on top of that green dot in my Fusion tree, which is going to add it as a union member of the Fusion item itself. Yeah? Have to be. Have to be. It is a rule inside of our library. Yeah, we can't change that functionality. In order to do mesh fusion, yeah. Yep. Yeah, they rely exclusively on the subdivision surface algorithm and the types of curves and profiles it's creating on the back end of the Modo library and the Modo database to generate the results that you're seeing here. Okay, so now that I've glued the little handle on, I want to show you a really neat feature. And I think the best way to showcase this feature is to turn off the visibility of all of my source meshes. Okay? And I want to talk about these transitions here. Because Mesh Fusion allows us to continue to refine and control the transitions between all of these different items. So in our case, the handle over here to the cube itself. Okay? Whenever we add a new item into Mesh Fusion, it creates what's called a strip, which is really a representation of the transitions between these two different items. From time to time, and quite frequently actually, you're going to have to update your strips. So I'm going to go over here. See how this is Fusion strips, update strip items. Whenever it would be great, and if the developer was listening to my live broadcast, it'd be great if they automatically created these strips, okay? Every single time we made a change. That'd be handy, right? But what I've learned is that it doesn't do that. So we'll have to update our strips, okay? After I hit that update strips, check it out. Once I mouse, now that I have a strip, I can mouse over the transition between those two different Fusion items, and you can see that we're getting a very faint little highlight. And I apologize, I understand that it's kind of difficult to see in the projector, but it's this light blue line that's showing up on the mesh itself. That's a visualization of the transition between my little handle and the cube itself. Check it out. I get to control this transition. If I click on that strip, whoop, I'm going to get a popover. I double-clicked on it on accident. There we go. I'll get a little popover, which allows me to control that strip. Specifically, what I want to take you guys down in here is this row of buttons. These two are going to break out individual controls of the strip. But what I do is I use the third one, because the third one just places both of these in one popover, which is really what I want. Okay, so if I click on that third one, we're going to get this groovy little, excuse me for a second, I zoomed in on accident. We're going to get this groovy little HUD down here at the bottom. And there's two channels that we get to control, strip width and strip profile. Okay? These are sliders. If we left click and drag on the percentage and on the numbers basically in the hull or in the HUD, we'll be able to interactively change these values. Let me zoom out, and I'm going to do strip width real fast. Okay? Oops. Oh, I apologize. I misspoke. If you left click on the number, you get to numerically enter it in, and then if you wanted to do the hull, you click on the name. I'm sorry. So if I increase, see that? How cool is that? You can now change the width of our strips, and it recalculates the surface for us, ensuring that what we're creating are all quad polygons or triangles, which are fine too. Okay. Awesome. We can even go in so the strip profile is really kind of a weight. You can make like a nice kind of chamfered edge or a smooth transition in between them. That's cool. Let's turn off the visibility of our wireframes. You can kind of more directly see the result in all this. I find often when the wireframes are on, you get a false read as to what the computer is actually generating because there's so much wireframe information in a, you know, the kind of the density of information gives you your brain, oh, like, what am I seeing here? So I turn off my wireframes to get a much better understanding of how all this looks. And this is just kind of miraculous to me because now I can individually go in and kind of change the way the transitions between all these surfaces are looking. Because this is way too tight down here. It doesn't look like they're kind of a member of each other. There we go. Let's make it bigger. I mean, try modeling that. That would just be really quite difficult to model. Okay? We can do this thanks to all those lovely strips that we're creating. So you got to click on the strip itself, right? See how I hover over what would be the transition between those two items? I get that little circle popping in. That's the strip. Now, if you don't have one of those, you need to update Mesh Fusion, update all the strip items in Mesh Fusion to generate that little circle. So click on Update. It'll go through, it'll triple check, make sure you have strips for everything, and then there's one down there. That's the one I was just messing with. Okay. Maybe it's a little too wide. There we go. And I have one over there. I actually have some in here, too, that I can continue to work with. So it's just a lot of control. I should have some up there, yep, that are defining that transition. So we get a lot of control here as to how all these pieces are being created. All right, questions so far. Let's look at a more advanced application of working with Mesh Fusion, because this is a good demonstration of how the technology works. But let's really throw it into a production environment and start building a model with it. If you look at D2L, I've given you guys some really cool parts and pieces. It's this Mesh Fusion rocket ship bundle of assets, and let's just look at it real fast. So here is a cool little rocket ship. Now I've modeled a majority of these pieces using a traditional modeling pipeline, and then at the conclusion of that, I've just transformed them all into Catmull-Clark subdivision surfaces. Okay. So let's jump in and start working with this, because what I want to do here is that I want to start, and let me turn my wireframes back on. Many apologies. Okay. What I want to do here is that I want to start using these pieces to create a much more, kind of complete result. And I got some work in here that I want to do. So here's the main fuselage. Then I modeled these things in here, which in every sense are going to cut the panel lines into the fuselage itself. I got my little fins down here that I need to glue to the outside, as do I need the cockpit. The engine needs some work. This is just a blank. I need to cut a hole in the bottom of the engine and then maybe add some compelling detail in here to give us a really neat result. And then I have this really great idea that we can do, I think, just with Mesh Fusion, to add some like exhaust ports coming down on the outside. All things we can easily do with Mesh Fusion. Let's check it out. It's pretty fun. Okay. All right. Let's do the easy, low-hanging fruit first, and we'll come back to the panel lines if we have time. So I'll turn them off. And same with fuselage inside. We don't need these. Let's get some stuff glued on here. So here's the outside, and I want to glue on the little fins down here at the bottom. So with those two things selected, I can go to my Fusion tools and start the creation of my Fusion item. And I'm going to call this just rocket ship. Rocket ship. And then I'm going to do, I'm going to turn on absolute strip width. I like doing that. That's just for me. And I want to do union of meshes to glue the fins to the outside of my, there it goes. Ah, wonderful. Awesome. Let's turn off the visibility of our source meshes and see what the product is, and it's looking pretty good. In addition, I think I'm going to go in and just move my tree out of the way a little bit here. There we go. So I can see what's going on. There it is. Cool. So this is looking pretty good. We even have the strips here. And this is why I love working with Mesh Fusion. I think this is just the coolest thing ever, is that I can glue these pieces together. And I'm using, I apologize, I'm using my pen tablet and it's double clicking on accident. Let me use my mouse. There we go. and I can go into my width and profile hollowing section and then change the width here. I think this is game changing for 3D modelers, right? Because now I can very quickly add that little cusp, that radius between these pieces. Doing this with using a traditional modeling method would be a tremendous amount of work. And the computer's doing, oops, zoomed in too far. The computer's doing a darn good job of doing that for me. Let's turn off the visibility of my wireframes, and that's pretty great. I like that. All right, so I glued the wings on. Let's get the bottom of the rocket ship's engine kind of working here, because there's a lot of work in here that I need to do. First and foremost, this is supposed to be an engine, right? So there should be a gigantic hole in the bottom of my rocket ship, right? Easily done with Mesh Fusion and maybe like a cylinder, okay? So if I go back to my cubic geometry preset library, let's do this. And I'm going to put in, which one here? I could do a cone. The cone may be fun. But I'll just do a cylinder just to make it easy. There we go. There's my cylinder. I'm going to turn on my wireframes once again. Let's raise this thing up and size her down some. Now what I'm looking at here is the thickness of I want the engine walls to be, and then the depth of my engine, the opening for my engine. That looks pretty good. So if you remember, to make that item a member of our fusion tree, what do I have to do? I want to subtract that cylinder from my rocket ship. You got it. It's drag and drop. And this is kind of speaks to the power of Mesh Fusion. I now can drag that item onto the red dot, bloop, and it's going to subtract it from my tree or from my object. Ah, wonderful. And that's pretty good. It doesn't have to be a very deep opening. I think that's compelling enough. Okay, so I want to put some more detail down here. The bottom of the engine is kind of bland. It really doesn't say engine, right? I think some additional geometry detail at the bottom will help kind of separate visually that part of the rocket ship from the rest, right? Because in my imagination, this is all like smooth, like aluminum metal up in here. And then this part down here at the bottom needs to be like a heavy kind of wrought iron or steel, something visually different from the rest of the mesh. Well, we're going to do that with geometry. We're going to separate it out with geometry. And let's do this. I think I'm just going to go grab a cube and smush it down some, like this one. Okay. Let's do this. I'm going to scale it down. I'm going to smush it to make it kind of into a thin block. And then move it up and out. And I'm going to rotate it too. So it roughly kind of matches the angle of my engine. Yeah, that's good. Oops, I messed it up. Yeah, right in there. That's pretty good. And let's get it into position now. Maybe somewhere in here. I'm going to change my action center just to selection. That way the X handle is right along that edge, and maybe something, I don't know, you have fun with it. Something like that. So the great thing about Mesh Fusion is that we can play around, we can experiment and see what the result gives us. Okay? All right, so I want to subtract that cube from my system, or from my fusion tree. Drop it on. Yahtzee, and there's the result. Let's turn off the visibility of our source meshes, and that's what it cut in, which is very cool. Very cool. I like that. I like that a lot. However, I need a bunch of them. Okay? I want these to go all the way around the base of my engine. So let's turn the visibility of my source meshes back on, and I'm going to show you a trick. And this is a great trick. I've selected the cube that's cutting that little indentation on out of my engine, and I shouldn't do this, but I'm being a 3D modeler. That indentation's way too thick, so I'm going to pull it back some. But this is what we can do with Fusion, right? This is why I love Fusion, because I can make these modeling choices. Take a step back. Let's look at it now. Yeah, that's better. That's much better. Oh, I like that. That's very cool. Okay. So now I want to make duplicates of that one cutter piece, okay? And I'm going to do this in my polygonal component mode. I'm going to do a radial array of that geometry, right? It's pretty cool. Since I'm working around the origin, I can do this pretty quickly when pairing the radial array tool with the origin action center. So let's do this. I'm going to go grab, now I'm in polygons now, and I'm working exclusively on the item that represents that shape. So I'm going to change my action center to origin and go back into my duplication tools and run radial array. Let's just click. Boom. I'm going to call that one done. Turn off my action center. Return to my Fusion collection of tools and deactivate source mesh visibility. And I'm pretty pleased with that result. That's beginning to feel and look like an engine on the bottom of a rocket ship. All done pretty quickly using the Mesh Fusion tools. Okay. All right, so step 1 done. Now, I think it'd be a whole lot of fun to maybe have some like really big vents, or maybe some sort of secondary booster on the side of the rocket ship, right? That'd be kind of cool, right? And I think I can create that pretty quickly using Mesh Fusion and maybe some simple unions and some simple subtractions, right? So how am I going to do this? Let's think through the process. I want to make the vent, and in my mind, this is going to be maybe the base mesh of the vent could be like a cylinder, and then we can chop the end of the cylinder off to get a cool angle on it. Yeah. Now it's going to have an opening in there too, so maybe I can be sneaky. Yeah, I'm going to be sneaky. Here's what I'm going to do. Let's throw in, we need some geometry first, right? So let's go grab a cylinder. Or maybe we'll use the cone. Ooh, let's use the cone. That way it's kind of tapered out. Me likey. Okay, let's get this cone into position here. That's a pretty extreme angle on the cone. And I'm going to change my action center to selection. Oops, let's look at it from this angle so we can kind of see what's going on. There we go. Yes, 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 yes. That's beginning to look and kind of feel what I want it to look like. May still be a little extreme. The angle's not right. I'm being a 3D modeler. For that, I apologize. Okay, cool. So that's the outside. That's going to represent the basic gist of it, of the outside of this vent, right? However, I want to also make the inside of it too, right? Because I want this to look like an engine coming out of the outside of my rocket ship. So since I'm going to be sneaky, and since I'm a good modeler, I'm going to think 8 or 9 steps ahead. And before I start adding all this stuff in, let's just I'm going to rename this. It's going to be vent outside in my item list, outside. And then I'll duplicate that item and call this one vent inside. Okay, cool. In the inside one, I'm just going to scale down a little bit and move it down so that it begins to create kind of a lip down there at the bottom. I'm very similar to what I did with the box a minute ago. I'm using a duplicate item that's the exact same shape, just a smaller version of it to create the illusion of width, thickness, if you will. Okay, that's a good start. Oops, of course it's going to crash on me. Boo. So this is a good opportunity to save your project file. Mesh Fusion likes to crash, or Modo likes to crash there's a lot of math and heavy lifting that's going on in the back end of this. Let's just see what happens. We'll wait a minute before I throw in the towel and raise the white flag. Does anyone know what this beach ball means?
You should try and open as many programs right now as possible.
What's it actually mean? A lot of folks think that the computer's crashed, right? It's trying to think, okay? The beach ball is not an indication that a crash is happening. The beach ball is an indication that it's thinking about way too much at the moment, and it's trying to process a lot of information. What you don't want to do when you get a beach ball is start clicking on things, right? That actually prolongs the resolution of this beach ball and adds a lot of issues into it, because whenever you click, the operating system is interpreting that click as an input and is trying to interrupt what it's currently doing to accept your input, right? So if you go open up another application or go check your email or start doing other things, you're actually making the whole system go a lot slower, and you're prolonging the problem. Now, I'm not saying that you shouldn't immediately close your application, but I always give it a minute or so. Let it think about it. You may get lucky, as they say. It may think about it for 5 minutes or so, and then get you back where you want to go. Okay? I can't tell you how many times I've seen the beach ball, and then I'm just like, okay, hands off. I'm done with this. I go to the bathroom, go do something else for 5 minutes, check Facebook on my phone, and then the computer will be done thinking about it. And then, of course, I immediately save my project file. But I think in this particular situation, Modo is deciding that it doesn't want to help me create my awesome rocket. And this has, in fact, crashed. So let's just force quit the app. We can do that down here in the dock by right-clicking on the app icon. This is usually a good indication that something has gone wrong. Application not responding, so let's force quit it. Yep, there we go. And I won't do the bottom of the engine like I did before. I'll just focus on this new bit just to kind of show us what's happening. You may get lucky with the autosave. Let's try it. Should we try it? Let's load. Let's see what the autosave pulled out. Hey, we generally got lucky. I don't put a lot of stock in autosave, but this time it helped us out. I got real lucky. I wasn't at autosave. I've noticed, and this is why I don't put a lot of stock in autosave, because I've noticed that autosave usually fires off at the most inopportune time, and I've had more bad experiences with autosave interrupting a big intensive, kind of processing intensive moment and causing the crash. Does more harm than good sometimes. But at other times, it saves my bacon like it just did here. All right, so let's just very quickly get back to where we're going. I'm going to duplicate that item, scale it down, and move it down, and then we'll create that little wall. Okay, so that's the outside of my vent. There's the inside. Let's go ahead and start putting these things in, okay? So that is going to be a union. So I'll drag and drop it on top right there. Glues it on. Cool. This is going to be a subtraction. I'll drag it on the subtraction node of my tree. And then let's see. Let's turn off the source mesh. Oh, that's interesting. So the first one, yay, that's cool. But look what's happening down here. Why are we getting that result? Yeah, the original cone was inside my geometry, so it's being subtracted and added to the outside of my model, okay? This is not what I want, right? This is not anywhere close to where I want. So what I need to do in here is begin making some big-time changes, okay? I want to isolate this entire operation from the base of my fusion tree so that when I start subtracting pieces from it, I'm not subtracting it from the base. I'm only subtracting it to the members of that branch. So let me go back in time a couple steps. Okay, and now we're going to make a new branch on the tree. Think of branches as a way to isolate areas on the mesh so that we can control just that one piece without having it affect the rest of our fusion item. Okay, it's a way for us to isolate. Now the method that we have to go through to create a new branch is funky, and it's my least favorite part of the fusion system. And if Daryl is listening, and Daryl is the guy that is the developer of Mesh Fusion, he needs to fix this. And actually, he has fixed it, in all honesty, because in 10.2, it's very different. But in order for us to create a new branch, we need to turn our source mesh visibility on, and then I'm going to grab what will be the outside of my vent, and I'm going to left-click and drag it onto the base right here. And then once I mouse up, I get a unique popover. And then inside of that popover, check it out, we have new branch with union, with subtraction, and with intersection. We're going to create a new branch, okay, with union. Let me go through that process again, because I remember when I first learned how to do it, I went, what? Okay, so you have to have your source mesh visibility on, okay? And we're going to drag in the viewport from here onto the source mesh itself, okay? Onto the base mesh, the mesh that initially was the first member of our fusion item, which for me is the fuselage of our rocket ship. And we'll get this fun little menu. and we're going to do new branch with union. It's going to think about it for a second. There it goes. And just look at our tree now, okay? Now, this piece is out on its own branch, right? It's isolated from the rest of my model, and I can control and edit and continue to work with it without having to wonder and worry that it's influencing the rest of my shape. Okay, so with that said, I'm going to start left-clicking it. Oops, I didn't want the strip. Here is the inside of my vent, and I'm going to drag it onto that subtraction node right there. Huzzah. Let's see what we get. Yeah, and that's exactly what I'm after. If you look at the source mesh now, it's subtracting the inside of my vent, but it's not subtracting any sort of content from the rocket itself, from the fuselage of the rocket. We've isolated this piece from the rest of the mesh. And now I can continue to control it however I want. I don't like the bottom of this. This is not really kind of what I'm after. I like the top of my vent. That's looking pretty cool. But I don't like this shape in here. I want to start refining it. Let's throw in another cube. Fusion assets, meshes, cubics. Let's go get our cube. There we go. And this cube is going to be, let's make it much bigger. This cube is going to help me define the end shape. Okay, and I'm going to change my action center back to selection just to make it a little bit easier for me to move and position and rotate this thing where I want it to go. I want to create a pretty steep angle here. Yeah, that looks pretty cool. Let's give that a try. So, once again, I'll drag from the OpenGL viewport onto the subtraction node of that branch. There we go. That's exactly what I'm after. The wall thickness in there is a little too intense for me. It's a little too thick. I want it to be a little thinner, and this is why we choose to participate inside of Mesh Fusion, is that I can go in and make a change. Make sure my action center is on selection. I can make a change here. Boom. And it updates the mesh for me in real time. Well, not in real time. It's kind of slow. When you start adding a lot of pieces in here, there's a lot of math. I mean, it's basically making a mesh for you in front of your eyes. It's outright magical, okay? So be patient with it, and that's damn good. I'm very pleased with that.
How does the exhaust come out of that?
I don't know. It's magic. It's magic. I try not to think too much about that. All right. Questions on? Yes, sir. Go ahead. Great question. It's as if you're reading my notes. What do we do with this thing after we've made the geometry, right? Because this stage is just all about creating the geometry. How do we create textures and materials and light and render this thing, right? Well, luckily for us, the guys down at the Foundry have done a really great job of producing that next step for us quite naturally, okay? So what we're going to do when we're done with this thing, and let's just pretend that we're done, okay, is that we're going to duplicate and convert this thing. Clean up my item list here to make it a little bit easier for you guys to see what's going on. So at the end of this entire stage, we're going to return to the Fusion item itself, and this thing here is the visualization of our Fusion item. And if we click on the root of this hierarchy, don't explore this stuff. You start messing around with all this stuff, you're going to break Mesh Fusion pretty quickly, okay? So you just need to select the root of this hierarchy, and then we're going to explore the properties of Mesh Fusion. And there's a whole bunch of them. There really is, okay? But most important, there's two things that we need to change. Right now, we've been actually looking at a draft preview, if you will, of the Mesh Fusion item. So we're going to change this from draft to airtight final with parts. And I'm also going to turn on Mesh Fusion UVs. If your source inputs, and this is what's neat about this, if your source input meshes have UV maps already on them, they're going to be automatically created and part of the Fusion system itself, and that's pretty neat. All right, so that's the first step. And then the second step, and because my interface is so small, it's getting truncated here, we need to output a mesh. Now we have three options. We can duplicate our Mesh Fusion item and then convert it to a traditional mesh item. Or we can do just duplicate mesh item and convert to mesh item. There's a reason this one's at the top, because this is the one that you're going to want to use almost every single time. With duplicate and convert, you keep your original Mesh Fusion item in your item list. That way, if you need to go back to it at any time, make changes, updates, tweak something, you still have all that information chilling in your project file. Okay, so let's duplicate convert. It's going to ask us to give us a name. Rocket ship mesh is just fine with me. I want to merge all the verts, create material groups. So let's do it. Let's create the mesh. It's going to think about it for a second. Hopefully it won't crash because it's doing a lot of heavy lifting, and it crashed. However, I'm going to be Julia Childs here for a second. Look what I have cooking in the oven. I just happen to have a duplicated and converted mesh already established for us. Okay, this is what you're going to get, and this really is. This is the duplicated and converted mesh of the entire Fusion item itself. Okay, from here we're going to get a traditional mesh item that's unreferenced by the Fusion system, that's unique and independent from the rest of the world. Okay, that we then can kind of roll into a traditional rendering and animation pipeline. It's a mesh like any other piece of geometry that we've created this semester. Okay. I can't remember if this version of my project file had UV maps in it, and this is actually kind of neat. We haven't talked a lot about UVs yet. No, this one didn't have the UV maps on it, but it's pretty neat that it will preserve all of your UVs. Good stuff, huh? Pretty cool. Yeah, it's a fun little rocket ship. I like it. This is going to roll into quite nicely our conversation that we're going to have next week, okay? Because one of the things that Mesh Fusion does a really great job of is creating what's called an airtight mesh, which is something that we're going to need for 3D printing, which is the next module in this class, okay? Next week, I want to bring out all of our 3D printers. We're going to start building some stuff. We're going to start printing some stuff. And every single one of you guys is going to make a model that you're going to print. Okay? So you're going to walk away with something in this class, which is going to be kind of fun. All right? Mesh Fusion allows us to create airtight meshes that are ready to rock and roll for 3D printers pretty quickly. Okay? And actually, you'll see this little spaceship rear its head again next week, because I've actually gone ahead and 3D printed this spaceship with the printers that we have here on campus. Okay? Questions so far? Everyone's kind of good? So that brings us to what we're doing this week. Okay? For our homework, I want you guys to have some fun. Oops. For our homework, there we go. For our homework this week, what we're going to do is build a rocket ship. Now, this rocket ship can literally be anything you want to make it, okay? You're making a rocket ship. You're just building a rocket ship. You don't even have to use the parts and pieces that I gave you, okay? If you want to try to copy the one that I did, you're more than welcome to. However, if you hand in the one that's called rocket ship end, I'll know pretty directly, okay? Because I've been looking at that project file for the last 3 years. Don't hand in that one. That's a bad way to get on my, that's a quick way to get on my bad side, okay? But I want you to make your own rocket ship. It can look nothing like the rocket ship sample that I gave you, or exactly like the rocket ship sample that I gave you, okay? Use these basic building blocks, these cubic library preset meshes, to build something cool, something fun, a rocket ship that, that you're pretty jazzed about, okay? I want you to be as creative as you can this week. You are building a rocket ship with Mesh Fusion. It can look like anything you want it to be. There's no limits, which is why I intentionally didn't give you guys any samples. Because I've noticed that oftentimes when I give you a sample of something, like half the class just builds the sample, okay? I want you to think creatively and conceptually and make something that you're pretty jazzed about, right? Mesh Fusion is a great way to add all these pieces in and start kind of designing in the viewport. And it's really a tool that allows us to do that pretty directly, okay? All right, questions, comments? I know that many of you guys are going to want to probably go back and look at this stuff So make sure you subscribe to my YouTube channel. I'm going to stop the live stream here in 2 minutes, and at some point in the next, I don't know, however long YouTube takes to put this online, it will be online. So if you want to go back and look at this, it'll be online. Carlos and then Mr. Moore. Yeah. Okay, cool. Yeah.
And our end product has to be fused together.
No, it doesn't have to be fused together. Yeah. Yeah, I want you to use Mesh Fusion because I think this is an important tool for us to learn. So use Mesh Fusion as part of your workflow. Some of you will choose to use Mesh Fusion for all of your workflow, but you're more than welcome and encouraged to mix and match. I'm okay with that. Yeah, it's going to be a fun one. It's going to be a fun time. We're just building something this week. All right, questions, comments? One little tip, and I've seen a couple people experience this. You saw me experience this. Save and save often as you go through this process. Mesh Fusion likes to crash, okay? Because it's just a lot of math going on the back end to make this stuff, kind of appear in front of us. Save and save often. Crashes will absolutely happen in this sequence, okay? All right, good luck, guys. We'll see you next week.